So in the previous classes, we have done the operations on set theory. First operation I told you that was the union operation. Then I told the intersection operation. Then I told complement of the set A. That also I told you. So these three operations already we have discussed. Now the fourth operation is the difference of sets that we are taking difference of sets. And in that case, if A is one set, B is another set, and we want the difference of the two, that difference will be denoted by this A minus B. From A, we are subtracting B. What that will be? X, where X should be an element of A. We should take the element of A, but X should not be element of B. We are going to collect only those elements which are in A but not in B. So we are concerned about the set A. Whatever element of set A, from that we remove those elements which are shared by B. We say X is an element of A, we are taking only those elements which are not in B or which are not shared by B. For example, A we have as 1, 2, 3 and 4. B set we have, it is 2, 5, 7. When I say A minus B, I will be taking the elements of A which is not in B. 1 is here in A but not in B. So yes, I can take that. 2 will be an element which will be element of A but shared by B. So I can't take this. 3 will be the element which is in A but not in B. So I can take that also. 4 will be the element which is not here also. So I should say 4. So we are concerned with the element of set A. We are not concerned 5 and 7. We are not bothered about it. A minus B means we are bothered about A. Only those elements we are going to select which are not gone in B or not shared by B. So A minus B means what? Those element of A, not of B. Those element of A which is not shared by B will be taken as A minus B. So A minus B will have element 1, 3 and 4. So A minus B is coming simply 1, 3, 4. That you should keep in mind. By the way, if they say B minus A, then what change in the definition? B minus A, if I take, it will be X, where X is an element of B. X should be an element of B, but X should not be an element of A. X is an element of B but not in A. So I am going to consider elements of B which are not in A should be taken. So here I'll consider now the first set B. This is the first set we are taking because B is here and this is A. 2 is here but shared by A. So I should not take this. 5 is an element which is in B but not in A. So we will take 5. 7 is an element which is in B but not in A. So we'll say this 7. So A minus B have 1, 3, 4. B minus A we have 5, 7. So we will have this way the difference of the two sets. If I just make the Venn diagram of it. First A minus B I am taking. When you are taking A minus B, it is 1, 2, 3, 4. 2 will come here. Here it will come 1, 3 and 4. And here it will come 5 and 7. Okay. 1, 3, 4. This is 2 and 5 and 7. When I say A minus B means 1, 3, 4. That is this portion only. That means this is the portion of A which is not shared by B. Just check this portion of A, that is 2, is shared by B, so we should not take this. So it is showing only A. This part actually represent A minus B, only represent only A. Only A means that part which is not gone in B. So A minus B will be this result. Same way if I say B minus A you take. That means it will be only B. Only B means it will be 5 and 7. Here it is 1, 3, 4. So only this 5 and 7 will be taken. This will be taken as B minus C. So this is A minus B, this is B minus C. So you can have difference of the sets. A minus B you can calculate, B minus A you can calculate. This will be called as difference of the set. One more operation is there, that is called symmetric difference. That also I tell, that is not given in NCERT, but you should know this. It's a very simple thing, not a difficult one, because A minus B, B minus A we have already done. So symmetric difference. Symmetric difference. What symmetric difference says? If you want the symmetric difference of matrix A and B, that is nothing but A minus B union B minus A. It is called symmetric difference A triangle B. Triangle is the symbol for symmetric difference. So A triangle B means A minus B union B minus A. Means what I am doing here, we are taking all the elements of only A, only B, common element we are removing. That means A minus B. A minus B will be this portion. This is your A minus B. This will be your B minus A taken together. Union means I am adding these two. So A minus B union B minus A will be giving as a symmetric difference. So symmetric difference of the two set will be clear now. That will be this portion only A and only B, not taken the intersection of the two. So that you should keep in mind. So now we are coming on one more example. Now we are starting the example. First example is, if there are the sets phi, then we have set A 1 comma 2, B set is 1 4 8, C comma is 1 2 4 6 8. When you have these sets, and now I'm writing phi and B, what symbol must come between phi and B you have to tell. A and B, what is the symbol we should write here? A and C, what is the symbol we should have? And B and C, what is the symbol you have? So these are the symbols we have to place. So when you think about phi and B, this is phi and this is B. What symbol I should have? Phi is an empty set and B is set 1 4 8. So one thing is clear already, we have done that phi is always a subset of B or A. Whatever set you take, it will be always a subset. So between phi and B, there will be a symbol we are going to have as a subset. Now we come on A and B. Is A here and B here? Is there any conditions here? Is this a subset here? No. Because 1 comma 2 is here and this is 1 4 8. 2 is not present here. This A is not completely in B. B is not completely in A. So what I should say in this case, A will not be a subset of B. So I should say it is not a subset. Then we go between A and C. What do you say? A is 1 2 and C is 1 2 4 6 8. What you should say about these two? Yes, they are. This is completely present in C, so I should say A will be a subset of C. Same way we go for B and C. What about B and C? 1 4 8 is here, it will be 1 2 4 6 8. It is completely present here, so we will say B is a subset of C. Okay, that you should keep in mind. So phi is a subset of B in this case. A is not a subset of B. A is a subset of C. B is a subset of C. Or you can write this way also. B contains phi. When you reverse it, B on that side phi. This also I told you. B contains. How you read it? Contains phi. What you will say? If I shift B here, then the symbol will change A. Then we should say B does not contain A. Here we'll say C and this is A. Then we say C contain A. And last is C here and this is B. So C contain B. So these are the symbols we should know. So if the sets are given, then we can decide what symbol should be placed in between. So this is one example I have taken. Now second example says, if X is an element of A is an element of B, then X will be an element of B. Is it true or false? You should find out. Question is, check whether this statement is true or false. If it is true, give an example. If it is false, give an example. So here in this case, now my question is, you have to check whether this is true or false, and whatever result you are stating as a true or false, you should explain it by certain example. So here in this case, X is some element of A. So let me take X is 1. Then A will be some set. A must be set here. X will be an element. Now A must be a set, should have this element. So let it be taken A as 1 or 1 comma 2, whatever you want to take. So A I have taken 1 or 1 comma 2 or 1, 2, 3, whatever. But this should have this element. Then it says A is an element of B. Means this set is an element of B. So what B should be now? B is another set which will have this as a one element. So that I should say 1 comma 2. Then maybe it is 3, maybe 4. This will be another set. Now check A is this is the element of B. So this is true. This is true. Now my question is X an element of B? This X is an element of B. Yes or no? Here in this case, X is equal to 1 and this is not having 1. So what you should say? X does not belong to B. If it comes, we will say, yes, our statement is not true every time. I have shown an example which contradicts the result. So if you show any example which will contradict it, we will say it is not every time possible. In few cases it is possible also. How it is, just check. If it is 1, it is 1 comma 2. Maybe I say here 1 and 4. Then what you will find? Is 1 member of B? Yes. So X is coming member of B. So few cases it is coming true and few cases it is coming false. Whenever this type of condition comes, in general we will say it is not valid. In few cases it is valid but not in general. So I should say final answer will be may not be possible, or in general it's invalid. In general invalid means in few cases it is wrong, in few cases it is valid. Clear? So that way you have two examples I have discussed. In next video we'll take more examples.